So let's take a look at unit vectors. First of all, what is a unit vector? Well, a unit vector is any vector that has a magnitude of 1, because that means it's 1 unit long. Now, it doesn't matter which direction it's pointing in. All that matters is that the magnitude of your vector is equal to 1. As a quick reminder, that vector with the absolute value sign around it, that means magnitude. So we're going to be using that a little bit as we go through here. So in order to find the unit vector, we need to figure out a vector in general. So let's take a look at a very, very simple vector. This vector right here points to the right. Let's go ahead and say that it points 3 units to the right. So in component form, this vector is 3, 0. Positive 3 means we move positive 3 units to the right. 0 means that we move up or down 0 to go from the initial point to the terminal point. So if I want to find a vector that has a magnitude of 1 that points in the exact same direction, I need to scale this vector down. So the first thing I need to do is figure out the magnitude of this vector. Well, because it's just pointing to the right 3 units, that makes it really easy. The magnitude of this vector is 3 units. Remember, magnitude is just a fancy word for length. So we're looking at a magnitude of 3 units. So I need to take this vector and I need to scale it down. How much do I need to scale it down? Well, in order to make it 1 unit long, I need to scale it down by a factor of 3. So I'm going to use some scalar multiplication to be able to get this vector to have a magnitude of 1. And once I do that scalar multiplication, the scalar multiplication is when you multiply this scalar number by each component. So I'm going to end up with 1, 0. So this new unit vector is a vector that points in the same direction as the original, so it still points to the right, but now it has a magnitude of 1 unit. And it turns out this is a very special vector. This is a very special unit vector. We use it so often in math that we gave it a name. We call it I hat, or sometimes a bold-faced I. Now it's really annoying to have to be able to scratch in this boldface, so that's why when we write just by ourselves, we tend to use I hat. If you're going to type it, you're tending to use boldface. But either way, that's a vector that points 1 to the right and 0 up or down. So let's take a look at another one. What if you've got a vector that goes up, let's say 5 units this time? Well, we're going to follow the same idea. The component form of this vector is 0 left or right and 5 up or down. Since it's a positive 5, we're going 5 up. Which again, finding the magnitude, very, very simple when you're looking at just a straight up, down, left, or right line. So our magnitude is 5 units this time. In order to get that unit vector, we want to make sure we scale it down. This time, our magnitude is 5 units, so we want to scale it by a factor of 5. So we're going to do some scalar multiplication on that original vector by saying 1/5 times that vector will give me 0, 1. So there's my unit vector. And again, this is another very special vector in math. A vector that points 1 unit up is used so often that we gave it its own name as well. We call it j hat, or again, bold-faced j if you're going to type it on the computer, but again, pretty annoying if you have to go ahead and make it bold every time. So this vector is a vector that points 0 left or right and 1 up. So let's take a look at something that's not as simple. But before we do that, let's think about what we're doing. Because really, what we're doing is we're taking our vector. So if we're given some vector v, let's go ahead and put an arrow above it to show that this is a vector. If we're given some vector v, then we can make it into a unit vector by taking our vector v and dividing it by the magnitude of v. This is going to be that official formula to figure out a unit vector. You take the vector and you divide it by its magnitude. So let's look at an example that's not super nice. So here's a vector that points up and to the left. Let's go ahead and put its components in so that we can figure out a little bit more information about this. It's going to point to the left 4 units, and it's going to point up 3 units, which, using your ideas of Pythagorean triplets or going ahead and doing Pythagorean theorem, will tell you that the length or the magnitude of this vector is 5. So the magnitude of this vector is going to be 5 units. Now again, these are not drawn to scale, so while these should be the same length, they're probably not. I'm not using grid lines, I'm just kind of eyeballing it. So if I want to find the unit vector of this, then I need to take my vector, my original vector. So the component form of that vector is going to be 4 to the left, so -4, and 3 up. So here's my original vector. I need to divide it or multiply it by 1 over the magnitude of the vector. So the final unit vector is going to be -4 over 5, comma 3 over 5. And if you don't believe that this is the unit vector, then go ahead and use your Pythagorean theorem to figure out what the magnitude of this vector is. And I guarantee you it should come out to be 1. And if you go a step further, you can figure out the direction. If you figure out the direction of this yellow vector up here, and you figure out the direction of this vector here, they should be exactly the same. And that's what a unit vector is. It's a vector that points in the exact same direction as the original, but only has a magnitude of 1.
I'm adding in one more practice problem here at the end, and I am doing this almost 3 years later, so you are going to notice a difference in the quality and all that kind of stuff, but I really enjoyed this video and I didn't want to have to redo the whole thing. There's no point in reinventing the wheel, so here's one more problem for you guys. So before we jump into this question, let me give you guys a little background on a very interesting thing called vector images. So I'm sure all of you guys have gone to Google Images at some point and tried to make one of those images larger. And if you make it too large, you'll discover that it creates pixels and it becomes very blocky. Well, if you're using something called a vector image, that'll never happen. Vector images are made up of mathematical equations and lines and dots, and they're specifically made so that you can scale them up and scale them down. So things like company logos, different sort of architecture drawings, those you want to be vector images. Because if you're going to put your vector or your company logo onto some big billboard, you don't want it to be some pixelated mess, and you don't want to have to create it in that exact size. If you make it as a vector image, you can scale it up or down as you need. So that's what this equation is basically doing, is it's showing us that we can scale something down and scale something up to whatever we want in particular. So let's go ahead and take a look at this problem. So in this problem, we have a vector, but it's not the size that we want. We want to change it so that the magnitude is 7. So while I'm looking at this, I already know that this vector is a little bit too large. I see one of the components is already 7, so the magnitude has to be larger than 7. So let's go ahead and draw this out and see what it looks like and see if we can scale it to a magnitude of 7. So I'm going to go 3 to the right and 7 down, again just getting an estimation of this. So now when I put in my components, forgot my line tool, I've got 7 there, and I've got 3 there. 3, and this time I'm going to do it with just positives, because the last one I used the negatives. So now if I want to find the magnitude of this vector, it's going to be the magnitude squared is equal to 3 squared plus 7 squared. So the magnitude is equal to the square root of 9 plus 49. And for those of you guys thinking ahead, you're going to notice that this is not a nice radical. So this ends up being the square root of 58. I can't simplify this, it doesn't end up being a nice number, so I'm just going to leave it as the square root of 58 for now. So now my goal is to scale it up to a magnitude of 7. Scale it down to a magnitude of 7. I'm not going to do that in one fell swoop. There are ways to do it in just one big ol' equation, but I'm going to make an intermediate step. I'm going to make a unit vector. So when I make a unit vector, that means that the magnitude is now 1. So the unit vector for this is 1 over root 58 times the vector 3, negative 7. So I have now effectively taken this vector and I've forced it to have a magnitude of 1. And that's super beneficial because I want it to have a magnitude of 7. So if I take this unit vector and I multiply it by 7, then I now have a vector that has a magnitude of 7. I've scaled it down and then scaled it up into what I want the vector to have a magnitude of. So there are some people out there saying, well, wait a second, you have to rationalize. I'm going to wait to rationalize until the very end. That's just my choice here. So 21 over the square root of 58 and negative 49 over the square root of 58. And now I'm going to go ahead and rationalize so that I get that square root out of the denominator. So 21 times root 58 over 58 and negative 49 root 58 over 58. So here is my rationalized vector. I can go ahead and guarantee you this does have a magnitude of 7. In addition, I'm going to go ahead and write this in its decimal form. So if I wanted the exact value, then it has to be this answer here. This is the exact value of the components that point in the same direction as this vector, but has a magnitude of 7. But if I want to just kind of get an estimate, so if I'm giving this to somebody to draw on a piece of paper or something, I'm obviously not going to give them this number. So instead, I'm going to write 2.757, going to 3 decimal places, and negative 6.434. So now if somebody wanted to kind of give a little ballpark of it, then we could use these values here. But this is now a vector that points exactly the same direction as 3, negative 7, but now it has a magnitude of 7. And again, this is used to scale images or objects up or down as needed.